So two more exercises that you can have a look at, exercise 71 and 72, which further problems on finding the surface areas of shapes. Again, it's up to you, you know, as many of those as you want to do. The more you do, the better you will get, okay? I'm going to giving out some required questions and exercises for the assignment, so those are the ones to focus on, but the more you do, you know, the better it'll be. So, but let's have a look at volumes now. So finding volume and surface area of shapes, which is the focus of the assignment. So I've taken these from the textbook, page, I'm not sure of the page, but it's chapter 20. So if you want to find that, chapter 20, which just follows on from what you were looking at, you're on chapter 18, so 19 is on the circle. Chapter 20, at the beginning of that chapter, you will see these formulae. And I want to focus on particularly the surface area. So if we look at this first one, the volume, length times breadth times height, fairly straightforward, okay? The surface area, though, if we look at the formula for the surface area equals 2, open bracket, BH plus HL plus LB. Look at that for a second. How is that formula arrived at, somebody? Yep. Yep. Right, okay, so I've actually got that the surface area equals 2 lots of BH, that's the front and the back, plus 2 lots of LH, which is the sides, and then 2 lots of BH, which are the top and bottom, if we're looking at it like that, okay? And then, you remember we talk about these little algebraic things. What's common to each of these terms, which element is common to each of these terms? 2. So I can take that outside a bracket, and I'm left with BH plus HL or LH plus BH. Okay? In other words, that formula there. So that's how it's arrived at. So if I'm asked to find the surface area of something, I could just use that formula. But it's making a big assumption, and that is that you want to find the surface area of a cuboid or a rectangular prism that has a top and a bottom, 2 sides and 2 ends. If this was an open top box, then you wouldn't include the top. So if you just use this formula without thinking about what this formula was saying, you would get an incorrect answer. So that's a big area of warning, okay? You have to think about what it is that you're finding the surface area of, and not just use the formula blind to find the surface area, because it's assuming that all the sides are present. If this was part of something that was fixed to something else, so I mean, I'm not great at drawing these things, but let's say there was something else over here that this was attached to, this end, and you were painting it, or you were in charge of buying spray paint to spray this thing that was stuck onto that, you wouldn't include that end here because it's attached to something. So you wouldn't use this formula blind to find the surface area that you're going to paint. If we look at the second one here, so this particular formula, again, the formula for the volume of it, any prism, and this is a prism is something that's got a constant cross-sectional area. So if I were to cut this anywhere and looked at the end, it would be the same. So that's the definition of a prism. So a cylinder is actually a prism, because if I was to cut this, I would have the same cross-sectional area. And the definition for the volume of a prism is it's the area of the end times the length. Area of the end, h times b, times the length. Area of the end, area of a circle is pi r squared times the length. So that's where this formula comes from, pi r squared h. Look at the formula for the surface area, though. How is that arrived at? What about this bit? Well, that's including this bit, but what's this part here, the area of? Yeah, yeah, the circle, which is the two ends, Daniel, isn't it? So why 2 pi r squared? Because we've got the two ends. So if you've not got the two ends, you don't include that part of the formula. You only include that bit. So this bit must be the side of the cylinder. How is that arrived at? Yep. Exactly right. Yeah, the circumference is 2 pi radius. So carry on. Yeah, the height, which is this bit. If I was to unwrap this, so that's exactly right. The circumference, if I were to unwrap that, I'd end up with a rectangle, and that would be height, and this would be the circumference, which would be 2 pi r. So how do I get the area of that? 2 pi r h, which is that. Okay? So that's the surface area of a cylinder. Worth thinking about how the formula is arrived at, because you don't always need to include every bit at the risk of repeating myself. Okay? So as when we come on to the assignment, these are compound shapes you're going to be finding in volume and surface area of. You really need to take that into account. Yeah. Not the one you got now, no, the next assignment. Similar arguments can be talked about to do with these others. A pyramid, volume a third times the area of the base times the height being the perpendicular height, so you might need to use Pythagoras to find that perpendicular height. The total surface area is just basically what it is. You've got the sum of the areas of the triangles forming the sides plus the area of the base. And similarly for the cone, volume is a third pi r squared h, but again the surface area is made up of the side plus the bottom, and so on. Okay? So there are some common formulae that you're not expected to remember, but if you're using these regularly in your particular line of engineering, then you'd get to know them eventually and you'd remember them. So you're always going to have reference to them. So those are the formulae. What you've now got to do is to use them. So same procedures we had before the break. I'm going to ask you to have a look at the exercises. So exercise 78, further problems on volumes and surface area of regular solids. What page number is that, please, somebody? Exercise 78? 164. It won't be that in the old text, but you'll have to find it. And it won't be 78, but you'll find it. Have a look at some of these, please. So again, I'm going to give you a period of time to have a look at it, and then we'll have a look at them together. If you're finding these quite straightforward, look at the other exercises that follow on. Okay?